In this video, we're going to be doing all the questions from the Cambridge A-Level maths exam from 2025, specifically paper 3.3. Now, it's going to be a long video. There's 11 questions in this paper. It'll definitely take over an hour, maybe up to 2 hours. I try to go in depth with each of my answers. I'm not just showing you what the answer is. I'm trying to show you how to do the answer. With that said, jump around the video as you like. If you're looking at question 4, use the timestamps below. Jump to question 4. Pause it, rewatch it, watch it at double speed or half speed, whatever you need to do. Before each question, I'll also throw that question up on the screen for 5 seconds. So you can pause it there and try it each time. If you're coming to this video from someone that doesn't do Cambridge A-Level, that's okay. It's all maths is maths. If you want to just try these questions, go ahead and try them. With that said, let's start off with question 1. In question 1, we're asked to sketch the equation y is equal to the absolute value of 3x minus 2. To do this, first of all, I'd like you to think of the line, the simple line y is equal to 3x minus 2, without the absolute value basically. Let's try and sketch that one. We take the minus 2 here, that's the y-intercept. That's where it'll hit the y-axis. And the 3 in front of the x is the slope. So that means it'll go quite steeply up. I'll put this in as a dotted line for a moment. The x-intercept here, we get that by putting y equals 0. So that'll be 3x is equal to plus 2. 3x is equal to 2, x is equal 2 over 3. That's this point here, 2 over 3. Now the problem is this line is not what they wanted us to draw. It looks very similar to it, but the absolute value does something. When something's positive, it leaves it alone. And when it's negative, it changes it positive. So this absolute value is acting on this line. So let's look at that line. This line up here is positive, 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 negative, negative, negative. So when it's positive, the absolute value leaves it alone. So we'll just fill that in a bit. But when it's negative, so at minus 2 here, the absolute value spits out plus 2. When it's minus 1, it spits out plus 1. When it's minus 3, it spits out plus 3. Basically what happens is this bounces up like that. We get this V shape. That's what an absolute value of a line will always look like. Sort of like it's bouncing off the x-axis. And that's the answer to part 1. What the examiner wants to see here is 2 over 3 and 2 and minus 2. They want to see all those points put in. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. In part B, they ask, hence or otherwise solve this inequality. Now there's a clue here, the hence part. What they're saying there, what they're getting at is, use what you've just done in part A to solve this inequality. There is another way to solve this. You could square both sides and find a quadratic you would and solve that inequality. That would work out for you. That's fine. If you'd rather do that, that's okay. But a much better, a much simpler and a more elegant way to do it is to use drawings, just like we did in part A. So how you do that is, in an inequality, take both sides separately. So for example, the left side will become y is equal 3x minus 2a, and we're going to draw that picture. The right side will become y is equal x plus 5a, and we're going to draw that picture, and we're going to draw them on the same picture. So let's set up an xy axis here. This guy needs, the y-intercept will be all the way up at 5a. This one, as we just did before, it'll be down at, let's say, minus 2a here, and plus 2a will be important. And you know, I don't really care where it's x-intercept, although we could solve it. Let's see, if that was 0, move this across, x is equal 3 over 2, 3 over 2a, isn't that right? no, sorry, 3 over 2 times a. So let's put that down here. 3 over 2 times a. So from the first part, we learned that this would look something like this. Fill that in, that bounce up. That's what the first part would look like. This second one at 5a, oh no, this goes up, I've just realised. So this is quite steep. This would be much more shallow. It would look something like that. Sorry, this one should look a lot steeper, and this one should look like a 45-degree line. But you should get something along the lines of this if you drew both of these on the same drawing. Now let's go back to what they asked us, the inequality. They're saying this is less than this. Remember, this one is the V-shaped, this is the straight line. When is the V-shape less than the straight line? It's everywhere between these 2 points. So to solve this inequality, we just want, the answer will be something like x is bigger than, bigger than or less than 2 numbers. And it's these numbers here, we now know. It's between these 2 numbers. It could have also, if this was greater than, it would be bigger than this number and less than that number. So really this question boils down to what's this number? What's this number? Find these points of intersection. So instead of this hard question with inequalities, we can write a question with equalities. So for example, this point here, that happens when the plus part, because we're on the plus part of this modulus, the plus part of this, 3x minus 2a is equal, this one, x plus 5a. We can go ahead and solve that, move that across, we get 2x. Move this, we get 7a. So x is equal to 7 over 2a. That's what this point here is, 7 over 2a. And that'll be part of our answer, 7 over 2a. To solve the other part, this is in the minus part of the modulus. The minus part of this modulus just looks like minus 3x, minus 2a, plus 2a. And we want to know when that equals this line, which is just x plus 5a. Go ahead and solve this as well. We get, let's see, minus 4x is equal to 3a, or x is equal to minus 3 over 4a. So that's over here, minus 3 over 4a. Or sorry, let me put it in here first. It's down here, minus 3 over 4a. So the answer to this question is everything between these 2 points. That's when this phi-shaped, this absolute value is less than this line. So that's your final answer up here. Okay, that's it for question 1. If you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching. Have a great day. In question 2, we're asked to solve the equation you see up here that's full of natural logs. So we're going to be using all the rules we can think of from logs. Remember how they add together, how they multiply, all of that. With that said, there is a certain order you have to do this in. For example, these two, they take away. Remember, take away and add are the same thing. We have a rule for 2 logs taking away from each other. They turn into divide inside their function. But this isn't a pure log. It's 2 multiplied by a log. So that's the first one I'd want to deal with. This whole line can be turned into natural log 2x plus 3. That 2, there's a rule for that. Anything multiplying outside a log can come in and become the power of the subject of it. And then we take away natural log 2x plus 5 equals a natural log 3x. Next thing that jumps out to me is 2 natural logs taking away. Oh, and before I go further, there is multiple different paths you could take through this. So just be warned, it's not, you don't have to necessarily do the way I'm doing it. It's the way I'm thinking of it though. When 2 natural logs take away, we can just divide what's in them. So what I mean by that is this would become natural log of this term here, 2x plus 3 squared, divided by this term here, 2x plus 5. And that will equal the natural log of 3x. At this point, we have natural logs on both sides. How do we get rid of natural logs? We would take the we'd put both sides to the power over e. So basically we put an e here on both sides. We're being equal to both sides, so that's okay. And the e and the log destroy each other. these destroy each other. We're just left with a normal algebraic equation in x. So what would you do next? You'd multiply this bottom row, try and get rid of that. So on the left side we'd have 2x plus 3 squared. We could square this out at any point. On the right side we'd have 3x multiplied by this. Let's do that now. 3x by 2x, 6x squared. 3x by 5 is 15x. And let's do it at this side. That's 4x squared. 6x plus another 6x is 12x plus 9 equals, I'll just write it out again, 6x squared plus 15x. We have a quadratic. We can just start rearranging this. Let's do it up here. Let's get all the everything on the same side, but I like to keep x squared positive. So we'll move everything over to the right. We'll get 6x minus 4x. It's 2x squared. Let's see, we'll have 15 minus 12, that's 3x's, and we'll have minus 9, and all that equals 0. We've reduced this down to a quadratic, which thankfully isn't too hard to solve, although if you have trouble solving these, feel free to use the minus b formula. That's always allowed. But the only way to get 2x squared is 2x times x, and then we have a couple of choices, 9 times 1 or 3 by 3 for this. Play around with it, but it's 3 by 3 works because 3 by 2 is 6 and 3 by 1 is 3. 6 and 3 can combine to get 3. Let's see, we need plus 3 here, so we'd need 6, a plus 6 minus 3 to get that. And a minus 3 by a plus 3 does get 9. This gives two answers. X is equal 3 over 2 and x is equal minus 3. If you leave this as your final answer, there's 4 marks in this question. I'm not sure what you get. You definitely don't get 4 marks. Most you get 3. Maybe you get less than 3, in fact, because there's something else they want you to account for. One of these answers isn't okay. And so I want you to pause it now and have a think why that is. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. The reason comes from these natural logs. Natural log cannot deal with something less than 0. So when they give you a question like this, they're basically saying that none of these are 0. So let's write them all out here. 2x plus 3, that has to be bigger than 0. They're telling you that. The fact that it's there means it has to be bigger than 0. That means x has to be bigger than minus 3 over 2. So this one's already out. So we can already discount that. But let's do them all at the same time. They're also telling you that 2x plus 5 has to be bigger than 0. That means x has to be bigger than 5 over 2. Again, this one's out. It's still out. This one's okay in both of these. Lastly then, they're telling you 3x has to be bigger than 0. That means x has to be bigger than 0. Once again, this is out. The only one left is this guy here. Just to be clear there, it wasn't important that this failed all 3 tests. If you fail one of these tests, you're out. All of these have to be true. And that means if you have to be bigger than 0, bigger than, so that should be minus 5 over 2, and so bigger than 1.5, minus 1.5, bigger than minus 2.5, and bigger than 0, you have to be all of them. That means ultimately you have to be bigger than 0. So this one is out. Your final answer needs to be a single answer. It needs to be 3 over 2. Okay, that's it for question 2. If you have any follow-up questions or you see any mistakes I made, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day. In question 3, we're asked to solve this integral that we're given here. The integral of 3 multiplied by cosine of 5x squared. Now this is actually quite difficult because you might try a few things here to solve this, replace it with, substitute it with something. I guess you could do try integration by parts because there's something squared means 2 things are being multiplied. None of that will work. When you have a trigonometric equation or an expression like this, it is always worth to check if you can replace it with something. Can you replace cosine squared with something? Obviously cosine squared plus sine squared equals 1 should jump to mind. That's not going to work out too well for you. We do have another option. Let me write it down here. We're told that cosine of 2a is equal to 2 cosine squared of a minus 1. So we are given this expression in our formulas. If we rearrange this, we would get something that would replace a cosine squared. So let me rearrange this. We would have cosine squared of a is equal, let's see, this guy plus the 1, and everyone would be divided by 2. So that means he'd be multiplied by a half and he'd be multiplied by a half. They don't write this explicitly in our formulas, but they write this, so we should be able to get to this. So let's go ahead and try and replace this question with this substitution and see if that makes it any easier for us. So we'll still be integral. I won't bother write my limits till the end. This will become 3 multiplied by everything in here. So that'll be 3 multiplied by a half cosine 2 times the original. So here's the original, 5x. 2 times that is 10x. And then plus, it'll be still 3 multiplied by this half. So 3 over 2. Integral we can separate this out. The integral of two things. It works sort of like multiply. So we can do this separately. We can just integrate each of them. Put a dx on this one and a dx on that one. This integral is quite easy to do. It's just a constant. This one's not too hard either. It's just a simple substitution. In fact, most students skip the substitution and just remember to divide by 10. So let's do it. I'll do this one a little slower with the substitution. So for this one here, I'll do a half quickly, I guess. I'd substitute u is equal to 10x. That means I would end up needing the derivative of du, the derivative of u, which is just 10. Rearrange this, I'd be able to replace dx with 1 over 10 times du. So this whole thing would become, let's say we'd move the 3 over 2 outside. This cosine of 10x would become cosine of u. The integral of cosine is just sine. So the integral of all this would just become sine of u, which I'll just write as 10x. The only problem would be we'd end up having to divide by 10. That's where this substitution comes in. Again, a lot of students just remember that the integral of a cosine with something multiplying by the x in here, you're just dividing by the derivative of what's in here. When it's simple, when the derivative is just a constant like this. Hopefully that was clear. Again, I think I'm overthinking this. Most students are able to do that. Then next we have the integral of just the constant. That becomes plus 3 over 2 times x. All of this is evaluated at the limits I've been leaving out. Pi over 4 and pi over 5. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. So let's go ahead and start putting them in. We'll clean this up while we're here. This is equal to 3 over 20 sine times 10 pi divided by 4. So what does that? 10 divided by 4 is the same as 5 over 2 pi. Plus we put pi over 4 in here. That becomes 3 over 8 pi. 2 multiplied by the 4. That's where we get that 8. Then we go ahead and take away putting this number in. That's minus 3 over 20 again, and we have sine of 10 times this. 10 divided by 5 is 2. That's 2 pi, and minus 3 over 10 times pi. You can use your calculator to get these two, obviously, but let me just do it with a bit of common sense. Here is a picture of sine. Here's 2 pi. Here's pi. So first of all, the easy one here, 2 pi is just 0. Sine of 2 pi is just 0. That goes to 0. What about sine of 5 over 2 pi? What is that, first of all? That's 2.5. So here's 2, here's 3. 3 pi is here. Here is 2.5. We're right in the middle here. This is a 1. This goes to 1, in fact. So this can all be done pretty much manually. This is 3 over 20 times 1. This is 3 over 8 pi. That's 0. Oh, we still have to do a bit of work. Minus 3 over 10 pi. Again, you could do this in your calculator, or you could get like terms, turn this into 40. We'd have to multiply by 5, so that becomes 15. Turn that into 40. We'd have to multiply by 4. That becomes 12. So this all becomes, let's see, 3 over 20. 15 minus 12 is plus 3 over 40 pi. And that's the final answer for this integral here. And that's the answer to question 3. If you, well, let me just double check it is the answer. Yes, that's the answer I got. Okay, if you have any questions, follow-on questions of this question, let me know in the comments. And if you see any errors I made, let me know as well. Okay, thanks for watching and have a great day. In question 4, we're talking about complex numbers, but they're in the polar form, or the Euler form, if you'd rather. And they give us a sort of proof. They ask us to show that the star they use, I'll write it in a moment, is the complex conjugate. Well, let me write it here. Basically, we're going to need Z1 star. That's the complex conjugate of Z1. We're going to need Z2 star. And we're going to find them. Then they want us to multiply these together. And they want us to then show that that's the same as Z1 times Z2 star. So we're going to need all 3 of these. To get this one, we're going to need Z1 multiplied by Z2. Let's do this one first. This is the easy enough one. The advantage of polar form, the really good thing about it, is that we're able to multiply numbers really easy in it. And if you're going to multiply a lot of numbers, that's a good thing to have. So how do you multiply 2 complex numbers in polar form? Let's do it a little slowly, I guess, down here. I'll write it all out. R1 e to the I theta 1 multiplied by R2 e to the I theta 2. And these are 4 things multiplying. Let me just put a little line under all 4 of them. These are 4 terms multiplying. Multiply doesn't care. You can rearrange it. So the answer is quite easily R1 times R2. They can be right up front. So whenever you multiply 2 of these, we just multiply this number in the front. That's it. That's it for the first part. Next, we have E times E. Let's write that down here. EI theta 1, EI theta 2. They have the same base. Think of what we know about multiplying 2 numbers with the same base. Their powers just add together. We just get I theta 1 plus I theta 2. They both have I in it. So we can take I outside and it's just the angle plus the angle. And that's how we multiply 2 complex numbers. It's nice and easy. Okay, next up, how do we get the conjugate? That's also nice and easy. Let me remind you what the conjugate is. Let's pick something like 2 plus 2i. The conjugate of this is 2 minus 2i. Nice and easy to get the conjugate in rectangular form. It's not too much different in this form. Let me draw that actually. I think that'll help. Yeah. 2 plus 2i comes over 2 up 2. 2 minus 2i comes over 2 down 2. Let me draw it in polar form. In polar form we need this angle here and we go out this length. It doesn't matter what that length is. I guess it's 4 plus 4, 8. Square root of 8 is this length. The conjugate is still here. This is still the complex conjugate. How would we get here in polar form? We'd just go, instead of this angle, we'd put minus that angle. This length would still be the same. So the complex conjugate of this is the length doesn't change, R1 doesn't change. EI, the only thing that changes is we get a minus here, minus theta 1, or we multiply that all the way up front, and minus theta 1. Same with this, it just becomes R2 E minus I theta 2. That's the complex conjugate. Now finally, we're at the point we can answer question A. They want to show that this multiplied by this is equal to the complex conjugate of this. First, let's get the complex conjugate of this. Again, it's quite easy. It's just this number, we don't change it. Or 1 or 2. E to the power of, this number just becomes a minus. This whole thing up here. So we just get minus I theta 1 plus theta 2. So they're both minus. If you can see, minus multiplies into both of them. That'll be important. Because let's try and multiply them. This time, well, let's write it down here. Z1 star multiplied by Z2 star. Well, that's just equal to or 1. Well, let's do it the same way we did here. Or, minus I theta 1 multiplied by or 2 E minus I theta 2. These multiply just become or 1 times or 2, just like it did there. They have the same base, so it's just e to the minus I theta 1 minus I theta 2. I'll just do it a little slower just to help show the examiner. This goes together just like it does up here, or 1 or 2 e. Minus I comes out of both of them, and we just get theta 1 plus theta 2, and you've shown that this is the same. If you ever want to get the complex conjugate of something, it doesn't matter if you multiply before or after. Complex conjugate works either way. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. In part B, they give us another complex number, or this time they give us the actual numbers of them, and they tell us that this is the root of this equation. And then they ask us to find the values of B and C. But they add in a little extra thing. They also say state the other root. So first of all, a little hint there. When they say state the other root, they mean you don't have to work it out. It's not hard to get. You should be able to just find it quite quickly. Now, interestingly in this question, you don't actually need the other root to find B and C. I'm going to show you, well, first I'll show you how to get the other root, and then I'm going to show you two different ways to find B and C. I think it'll take a little while, so if you rather one than the other, skip to it and so on. First, how do we state the other root? To show you that, I just want to point out this is a quadratic equation. You probably remember a formula to solve the quadratic equation. In this case in Z would be minus b plus or minus the square root of something, I won't bother writing it in, over 2a. Now this formula will get you the root of usually two roots of any quadratic equation. In this case the root is a complex number. Now where does a complex number come from? A complex number comes from a square root of a minus number. So that's where they appear. If they're in here as a minus, we're going to get a complex root. And look what's here, plus or minus. So the answers we'll get will be something, let's call it x plus something I in a complex number. And there'll be a plus or minus there though. So that's why, I haven't said it yet, but that's why the other root, when you know one root and they're complex numbers, the other root is just the conjugate. It's just x minus that. So the other root in this question is just the conjugate of z, which as we did previous, it's just 3e to the minus pi over 4i. Just need to change sign. So that's when they say stated, that's all they're looking for. With that out of the way, how do we find B and C? The way the examiner probably wanted you to do it, because they asked you to find the other root, was to multiply the two factors. If this is a root, we just get z minus this, they're the factors, multiply them together, it will equal this. I will do that in a few moments, but I don't think it's as nice an answer as what you probably should usually do when they give you a root. Just put the root in. And now I said you only need one. Well, I'll explain why you only need one in a moment. Pick whichever root you want. I'll just go with the first one they gave us. And I'm going to put that in there, z squared. So z squared is 3 times 3, that's 9. E to the power of pi over 4i multiplied by itself. That just means there's two of them. So just multiply this number by 2. That's how you get the power of. Let me write that down. 3 by 3 is 9. E pi over 4 I times E pi over 4I. Remember, they just add these together. So that will just, I don't want to use up half the board, so I'll just put it in here. 2 pi over 4 is just the same as pi over 2I. Okay, what else have we got? B multiplied by Z. Well, that just becomes 3 times B e to the pi over 4I plus C equals 0. Now, you're probably thinking, surely I need to put the other root in to solve this. There's one equation with two unknowns. I don't know C and I don't know B. But not quite. This is a complex equation. There's real parts to this and imaginary parts. That means we can actually get two equations out of this. But there is a problem. The great things about polar form, there's lots of great things about it, but one of the bad things is the real and imaginary parts are squashed together. And they're in here, well, both of these are squashed together. This one works out quite nicely. So really, to get two equations out of this, like I want to, we're going to have to turn these back into rectangular form. So let's just go ahead and do that. There's quite a quick way to do it, which I will show you as we go through it, and I'll do it in the second part. But first, you can just think of it as drawing a picture. Draw a picture of this guy. We go to the angle first. Pi over 2, that's 90 degrees. Start here, go up 90, it's on this line. It's 9 up this line. So this point is actually 9I. So we can turn that into that quite easily. This one, pi over 4, that's less easy. It's over here somewhere. And it's 3b up here. That's less easy, but to help me with that, I'm going to draw a triangle. And again, there's shortcuts to here. Let's see, triangle here, that's a right angle triangle. This length here is 3b. I want to know this length, and I want to know this length, because that'll tell me the real part and the imaginary part of this point. Now, I know this angle in here, that's pi over 4. There's two ways to do this now. I don't want to branch out too many times. But if this is pi over 4, that's pi over 4, which means these lengths equal each other. So you can use Pythagoras theorem to solve this. But that only works this case. Something that works all the time is using trigonometry. I'll do the first one slowly. Let's try and find this length here. Let's call this one y and this one x. I know they're equal because that's 45 degrees, but bear with me. To find y, we could find that by saying sine of pi over 4 is equal to y over 3b. That's opposite over hypotenuse. Rearrange this, we'd get y is equal to 3b sine pi over 4. And sine pi over 4, if you put it in a calculator, it's just 1 over square root of 2. So this becomes 3b over square root of 2. That's the y part. That means the imaginary part of this is this times I. Find x, you'd find x very similar. Rearrange it, you'd end up getting x is equal to 3b cosine pi over 4, and that would equal 3b over square root of 2. Let me point out the shortcut if you don't see it. If we ever want to break this up into a real and imaginary part, here's the real part here. The real part is just 3b, that's the number out front, multiplied by cosine of this angle. 3b cosine that angle. You've got your real part. The imaginary part is just the bit out front, 3b, multiplied by sine of the angle, and then just add an I onto it. So the imaginary part has an I. So let's write this equation again. Let's just put a bit of space down here to fit it in. 9. This became 9i. That was quite easy. That's 9i. The real part of this was 3b over square root of 2. The imaginary part of it was actually the same, 3b over square root of 2, but it has an I in it. And we have plus c equals 0. I'll clear off the rest of the board so we can do this. But now we have one equation with two unknowns, but it's imaginary. We have real parts of it. So this part and this part, which must equal 0. And we have imaginary parts. This part must equal 0 as well, because there's no i's over this side. There's 0 i's on the right. And if you notice there, 9 and 3b over square root of 2 and 0, there's only one unknown in that. So let me clear off this and we'll solve this for b and c. Let's write out the real parts of this equation first. We have 3b over square root of 2 plus c equals 0. We can clean this up, but there's still two unknowns, so we're a bit stuck there. The imaginary parts, we have 9i here. We have 3b over square root of 2, and that must equal 0. We can solve this. There's only one unknown here. Rearrange it. Becomes 3b, this becomes minus 9, multiplied by square root of 2, and then we'll divide by 3. So b is equal minus 9 divided by 3 is minus 3 square root of 2. That's the answer for b. For c, it's just here. C is equal minus this. So minus 3 over square root of 2. I've just moved this over. Multiplied by b. But sure, b is just here. So that's minus 3 square root of 2. Square roots cancel. Minus 3 by minus 3 is equal to 9. They're your answers for b and c. I'm going to clear this off and do it again. Like I said, I'm going to multiply two factors together. We'll get the same answer, but it'll be a different path to get it. There'll be a lot of similarities though. We'll still have to break something up and find the real and imaginary parts. I just think this way was a little shorter. Even though I'll try and make the second way shorter because I'll use the shortcut when I'm breaking these apart. Okay, instead of putting the root into the equation, if we took the factors are z minus 3e to the power of, that's just pi over 4. I've just moved that over the equals to get the factor. And if we multiply these factors together, this one is, let's call this z as well. Sorry, this is just the two factors, and they're both z. I hope that's not confusing. Z minus 3e to the minus pi over 4i. If we multiply these together, we should get this. It's actually quite easy to find c using this way. So this way it'll be very easy to find c, but b is going to be a bit of a mess. Let's just multiply it all out and we'll get z squared. Z by z. Z by this, we'll get minus 3z e to the minus pi over 4i. Minus 3, this term by this z, we get minus 3z e to the plus pi over 4i. And then finally we get minus by minus, we get plus 9 e to the pi over 4i. And we'll add this. We're multiplying them now, so we're just going to add this, which is minus pi over 4i. These add together to get 0. They cancel. That's just 0. E to the power of 0, that's just 1. And we're left with 9. Just 9 here. So we have z squared, we have terms with z, and 9. So I already know c is 9, which I knew was the answer. Now in this case we're adding two numbers that's complex conjugates of each other. So there is a shortcut here. Have a think what it is. I'll point it out as we do. I'll do it the long way and not use it. But think what happens when we add two complex conjugates together. Okay, let's just break them both out like we did previously. Z squared, we'll leave alone. This becomes minus 3. The real part of this is minus 3 multiplied by cosine of minus pi over 4. I don't know why it's up there, sorry, let's put it down here, minus pi over 4. And then the imaginary part is minus 3 sine minus pi over 4. This guy, the real part, sorry, there's an I on this one. The real part's minus 3 cosine pi over 4 and minus 3 sine pi over 4. And we still have a plus 9 out here. And sorry, all of these have z in it, don't they? So they all have a z in it. So the number in front of all the, because we could group all the z's together, all of these added together is just what b is. So that's all we need to do. Add them all together to get b. And you could just throw them all into calculators really. We get z squared, leave alone. Then the two real ones, this one and this one, that's minus 3z. Cosine of minus pi over 4 is 1 over square root of 2. And so is this guy really. We'll just get minus 3z minus another 3z both over square root of 2. So we'll get minus 6z over square root of 2. This one will come out as minus 1 over square root of 2. and this will come out as plus 1 over square root of 2. Otherwise they're the same. They should have an I in it there. So these will actually cancel each other. They'll just take away from each other. And let's see, we're left with just plus 9. Plus 9. So from this way, we can just see the answer B is minus 6 over square root of 2, which is different. Previous we got B is equal 3 times square root of 2. It's actually the same. Sorry, minus 3 square root of 2. It's actually the same. Minus 6 over square root of 2 is the same as minus 3 times 2 over square root of 2. 2 divided by square root of 2 is square root of 2. So, same answer. I said, have a think what happens when you add something with its conjugate, which is what we did here. And if I go back to that drawing I had, here's a number here and there's its conjugate down there. When we add them, we get an imaginary number and minus the imaginary. We knew these imaginary numbers would cancel, as they did here. I knew they would cancel. And we're just left with its real part, but we have 2 of them. So it's just 2 times its real part. So you could have just got either all the way up, all the way up here, these two. When you notice these are conjugates of each other, you could have got either one of them and got its real part and just multiplied by 2. So minus 3 cosine of either of these angles multiplied by 2. Could have jumped right to that point. So maybe I was too hard on the examiners earlier. Maybe doing it this way is shorter when you know how to make that leap, which I don't think it was that clear. Okay, that's it for question 4. I went on quite long on that, but it was an interesting question. There was lots of different paths to it. There was lots to learn from it. There was very, very smart ways to do it. You could have done this question really fast if you knew how to do it. And if you're watching all this video, you probably needed a little help. Okay, thank you for watching and have a great day. In question 5, part A, they give us this equation to start with. And they also give us dy dx is equal to a big mess. Now, I haven't wrote that down because they often do this. They want you to show that happens. They do that just so you have that question ready for part B in case you can't finish part A. I think it doesn't help students. Well, it does later in the question. It can sometimes distract students seeing it there. So I say don't put it there yet, just try and get it. Later on in the question, when we get close to being finished, we go, okay, does it look like what they wanted it to look like? Often you have to, which we will have to in this question, often you have to readjust it slightly. So really they want to find dy dx. That's what I take away from show that dy dx equals. Just find dy dx. What you'd like to do here is find y equals and then just differentiate. You can't do that, it's too complicated. The y is too mixed up in this. You'd have to use the quadratic formula and it'd become a whole mess. What we can do is use implicit differentiation. What that means is we can differentiate both sides. So we'll just differentiate without a subject. So usually it's dy dx because we're differentiating y. Or it's if you were differentiating x squared, you might write dx squared with respect to x. In this case, we're just going to differentiate the whole left hand side. So let's just put it in a bracket. Y squared e to the minus x. And to be equal, we're going to differentiate the whole right hand side, which is just 4. This right hand side is going to be nice and easy to do. It's the left hand side that's going to give us a good bit of trouble, but not too bad. First of all, differentiation works sort of like multiply. We can take each of these separately. So I can already separate this out as we're differentiating xy plus we are differentiating y squared e to the minus x. What we have here is the product rule. We have 2 things multiplying. Now they're difficult things to do, but they're still just 2 things multiplying. The right hand side, let's just do right now. The derivative of a constant is just 0. How much does x change when 4? It's 0. It doesn't change at all. How much does x change when this changes? Yeah, probably a good bit. Okay, how do we do this? Product rule. I just differentiate the first thing. So I get 1. And I leave the second thing alone, multiplied by y. Plus I leave the first thing alone and multiply by the derivative of the second. How do you differentiate y? It's just dy dx. This is the secret of implicit differentiation. This is what we want to get. We'll see what we do with it in a moment. So that's a derivative of this, as best we can do. This one's somewhat similar. It's two terms. Let's differentiate the first one. So this is this plus here. I'm putting differentiate the first one. That's hard in its own right. What's the derivative of y squared? Well, we use the chain rule. First, we assume that we're differentiating with respect to y. So y squared becomes 2y. But that's a bit of an assumption. That's what the chain rule does. We're sort of saying, forget doing it by x. Let's do it by y. It's much easier. But we can fix it. Let me just write that over here. D y squared here is what we're trying to do in the middle of this question. That's the same as doing y squared with respect to y. That's the cheat I'm doing. Once I fix that cheat with dy dx, basically these dy's cancel. So here, instead of differentiating the first part, y squared, with respect to x, I get 2y. I differentiate with respect to y. Now I need to multiply it by dy dx. That was all just this guy differentiate. Then we leave this one alone. That's the product. We're back in the product rule at the moment. Next, we leave this one alone. So plus, we leave that one alone. And we differentiate this one. We can also think of the chain rule. Differentiate with respect to minus x instead of x. Or you can just look up certain rules of differentiating with something multiplied by x. Either way, we get... I think of it as the chain rule. I think of it differentiate with respect to minus x. So it just means nothing happens. But then we have to multiply by the derivative of what's up here, which is just minus 1. So this gets multiplied by minus 1. So we'll just change that to a minus. Okay, let's clean this up. Oh, sorry, this is all still equal to 0. Let's clean this up as best we can. Actually, there's not much to clean up. So let's already skip to the next step. We want dy dx, and there it is. So let's just get it on its own. Let's isolate it. dy dx has a few things going into it. Dy dx, and this one has x going into it. And here it has 2y times e to the minus x. And let's move everything over the other side. This becomes y squared e to the minus x, this term here. And this one becomes minus y. Let's divide both sides by that and we get dy dx on its own. dy dx is equal to y squared, e to the minus x minus y divided by x plus 2y e to the minus x. We're done. We just want to double check that's what they wanted us to find. And unfortunately it's not. It's not quite. It's close. They wanted a y squared minus a y. They wanted an x plus a 2y. So we're very close. Just all these e to the minus x's. They're not where they should be. They have e to the x here and here, not here and here. So what's going on? And let me just clear the board so I have a bit more room to show you. So let me rewrite this over here. But instead of e to the minus x, I'm going to write that as divided by e to the x, because that's what that minus does. So this minus y, there's nothing special about that. Divided by x, there's nothing special. But this 2y, he gets multiplied by e to the minus x. So that's the same as divided by e to the x. I could rewrite that, this here as that. The problem is, we don't like divide. We don't like dividing by things, so let's get rid of it. To get rid of this, we multiply everything, top and bottom, by e to the x. So e to the x on the top, e to the x on the bottom. We can do that whenever we want because, look, it's like multiplying by 1. This divides that. It's like multiplying by 1. But here's the great thing it does. It multiplies by both of these. Multiplied by that, we get just y squared. These cancel. Multiplied by this, we get minus y e to the x. That's what they have on their top row. On the bottom row, we get this by that. That's x by e to the x. That's what they have. And this cancels with that. And we get plus 2y. And that's how we get the equation they had. I think they'd take a mark down here. I'd like to say they'd only take half a mark. But I'm not sure they're even allowed to do that. But I think they should only take half a mark. But you might lose a whole mark for that. Okay, let me clear off the board and we'll do part B. Before we do part B, let me just go back to part A for 1 second and point out a little cheat you could probably get away with. I said if you left your answer what we had here, you might lose a mark, half a mark. A nice little cheat would have been, you knew the answer should be this. You knew it looked close to that. You could just wrote equals this, and the examiner would probably have gone, yeah, okay, you did it all in your head, that's fine. It's a bit cheeky, you won't get away with it all the time, but in that case you probably would have saved yourself losing a mark if you didn't know how to get from that step to the one I wrote over there. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Anyway, let's on to Part B. Part B, also remember in Part B, if you weren't able to do Part A, you're back in the game for Part B. All you need is these two equations, and they gave you that in Part A. So even if you didn't get anything in Part A, you can do Part B. They want you to find the gradients of the tangent to the curve. This is the curve. The gradient is this. dy dx is the gradient. They just want dy dx when x equals 0. So you could try, this is going to be wrong, but you could try doing this, dy dx when x equals 0. Just put it in, we get y squared minus e to the power 0 is 1. So we get minus y over 0 times anything is 0, that's gone, over 2y. So maybe that's your answer. You might get a mark for that. But no, they want a number. This isn't right. I'd love to know what y is equal. So what we should have done at the start is find out what y is equal. We have everything we need here. There's an equation with two unknowns, and they told us what x is. So we have one unknown. Let's write this equation out again. 0 times y, 0. Plus y squared, e to the power of 0, just 1. So what do I have? Plus there. Y squared basically we have. This is 0, this is 1. We have y squared equals 4. We have y is equal plus or minus 2. And that is important that you get the two answers there. Not one answer, two answers here. So instead of x equals 0 putting in, we want to put in y equals 2. And then, yeah, let me do it down here. And then down here we'll do it again. Just do it all over again. X equals 0 and y equals minus 2. And we get two answers. So this one, we've already done most of the work. We put 0 in for x. Let's put 2 in for y. That becomes, what's that? Sorry, that's 4 minus 2 over 2 times 2 is another 4. It's 2 over 4, which is the same as 1 over 2. That's an answer. That's one of our answers. They ask for gradients of tangents. So they want more than one answer. Here's one of them. The other answer, let's do this straight from the start. Minus 2 goes in here, it would be 4. Minus 2 squared is 4. Minus 2, that's plus 2. E to the power 0, that's 1, so plus 2. Bottom row, we get 0 times anything, it's gone. And then 2 times minus 2, that's minus 4. This is equal to 6 over minus 4, which is the same as 3 over 2, or sorry, minus 3 over 2. There are your two answers. The gradient's either half or minus 3 over 2. And that's it for question 5. If you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day. For most questions, I tell students if you just try them, you should be able to pick up lots of marks. This is one of those questions where I think it was very difficult to even start it. If you weren't sure what to do, you could get in a lot of trouble even starting this question. What we have here is basically two clues they've given us. They've given us two clues, and ultimately they want to find z, the x and y part of z. The two clues they've given us is the fact that this division here is real. That's one clue. The next clue they've given us is that the modulus of z is the square root of 10. We're going to use both those clues to try and solve it. They tell us, which is quite helpful, that z is equal to x plus yi. This is extremely important because I'm guessing a lot of students seeing division, seeing z plus 4i on the bottom row, and went ahead and multiplied this by z minus 4i to try and get rid of the bottom row, to get rid of this its complex conjugate on the bottom row. there's a problem with that. That's not going to work out for you because z minus 4i is not the complex conjugate of the bottom row. That's because z has an I inside it. Z is made up of a real and an imaginary part, and you have to respect that. So we are going to get the complex conjugate. We're going to divide this, but instead of this, we're going to write this out as x plus yi plus 4 divided by x plus yi plus 4i. And we are going to get the complex conjugate at the bottom, but I think it will help to rewrite this again as x plus 4, put a bracket around it, plus y. I'll put a bracket around that just to make it really obvious. This is the real part and the imaginary part of the top row. The bottom row, x is the real part and the imaginary part is y plus 4. And they're both multiplied by I. That's the imaginary part of the bottom row. When we're dividing, we multiply by 1, which is the same as multiplying by something divided by itself, which is the same as multiplying by the conjugate divided by itself. And we pick the conjugate because the conjugate would make the bottom row real. Oh, by the way, I don't have to do all the work I'm about to do. Well, I'm not going to do all the work it seems I'm about to do. I'm going to stop them. I'll talk more about that in a moment. Let's multiply this, put a big bracket around that, and multiply this by the conjugate at the bottom. That's x minus y plus 4. Remember that both of these are minus. Minus goes into both of them times I. And x minus y plus 4 I. And we're multiplying by all of this. This would be a mess. We have 3 terms on the top. 3 terms everywhere, in fact. So these 3 terms by these 3 terms would get 9 different terms on top, 9 different terms on bottom. We'd have to put them all together. It'd be a bit of work, not too hard. I'm guessing a lot of students did do that. It's fine. You probably only cost yourself an extra minute or 2. But also you added in the possibility of making loads of mistakes. So I'd like you to consider now what you could have saved yourself time on. They never asked us to do this. We weren't asked to divide this by this. All they did is they told us that if you divide it, the answer is real. What does that mean? That means there's no imaginary numbers in this. Now we know there's no imaginary numbers on the bottom because we're going to multiply it by its conjugate. That's what it does. It destroys imaginary numbers. If you multiply this bottom row out, the i's will just cancel each other and we'd just be left with loads of numbers. That's fine. What they're telling us is if we multiply this top row out, there should be no i's. But if you do it, there is i's. So that means they all add up to 0. Maybe we get like x plus y I. That means they must x plus y must equal 0. That's what they're telling us. So the work we can save ourselves is we're not going to multiply this. We're going to think about it. Where do all the i's come from on the top row? Bottom row, I know they're gone. But on the top row, where will an I come from? This real number by this real number. No, that's not going to make any i's. This real number by this imaginary number. Yes, that will have i's in it. This imaginary number by this real number. Yes, there will be I there. And this imaginary number by this imaginary number. No, 2 imaginary numbers will get turns into -1. Okay. So all I'm interested in is this real number. Let me write it out again. X plus 4 multiplied by this imaginary number. So multiplied by minus y minus 4. Let's write it like that. Multiply this minus. Can't forget this minus here. This will have an I in it. Sure, I'll cancel that in a moment. Then I'm interested in this one by this one. That's y multiplied by x. And that will have an I in it. But I know this has to equal 0 i's. So we just cancel all the i's there. So this is the information I'm going to get from the fact that this is real. So let's clean this up a bit. We get minus xy minus 4x. I'm just multiplying this all out. Minus 4y minus 16 plus xy equals 0. We have xy and xy. They cancel. We have everything divides by 4, and we've moved the 16 over. So let's divide everything by minus 4. We'll get x, we get plus y, we'll get plus 4, or equals minus 4. This is the information we get out of the fact that this is real. Again, if you multiplied all of this out, you would have had a big mess, But hopefully this would have been this here would have been part of your mess. They would have cancelled. You should have had this with I here, with all of these with an I in it. This should have been in the mess that you multiplied out. The secret to this question, the leap you had to take, was the fact that all of this must equal 0 if it's real. And you should have got to this information. We're not finished yet. We have 2 unknowns, 1 equation. We need a second clue. And that's what this tells us. The modulus of a complex number. This is the same as the modulus of x plus yi. Sorry, the modulus of it. And that's equal to, remember, this is, you could just think of this as drawing if you want. What's the length here? When you know this and you know that, it's Pythagoras theorem. It's this squared plus this squared, the height of a squared, and the square root of it. But they're telling us that equals square root of 10. So just cancel the square both sides. We just know x squared plus y squared equals 10. We have, 2 clues, this one and this one. 2 unknowns, 2 equations. This is a simultaneous equation, a quadratic simultaneous equation, sure. But this is something we've learned how to do. We can solve this. Let me clear the board off and we'll do just that. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. I didn't mean to rub out the actual question or the clues they gave us, but we've reduced everything down to this, solving this simultaneous equation, which is also the same as a line hitting a circle, by the way. But how do we solve this? Rearrange the simple one here. So it's x is equal minus 4 minus y. Or you could have got y in its own as well. And we're going to put this into this. So that's, instead of x squared, we're going to put that. Minus 4 minus y squared plus y squared equals 10. 1 equation, 1 unknown. Let's multiply it all out. We get y squared minus minus by a minus is plus 4y, and there's 2 of them. So we get 8y's. We get plus 16 here, plus another y squared equals 10. Add all these together, we get 2y squared plus 8y. 16 minus 10 is 6 equals 0. Everything, 2 goes into everything. So we get y squared plus 4y plus 3 equals 0. Quadratic equation comes down to, if you're not good at factorizing, use the minus v formula. But this one does work out quite nicely. Y times y, we'll get y squared. 3 times 1, we'll get 3. And this does work to get 4. This plus this. Plus 3 plus 1, we'll get 4. So this all still equals 0. So y plus 3 must equal 0, or y must equal minus 3, or y must equal minus 1. Don't stop here. So many students stop at this point and they just throw away a mark. Maybe 2 marks, because the examiner might just have to give a mark for each of the 4 answers. The other answers are the x's. You still want your x's. X is equal minus 4 minus 3. So instead of y, we put minus 3. That's minus 4 plus 3. That's x is equal minus 1. Same here, x is equal minus 4 minus 1. So that's minus 3. You could have got x's as well, by the way, because a circle is symmetrical. So you could have just said that if minus 3 is the answer on this side, these go together and these go together. If minus 3 is the answer here, minus 3 must be the answer for the x here. Anyway, this I think you get full marks at this point, but you can still write this as minus 1 minus 3i. So that's the real part and the imaginary part. That's the real part and the imaginary part of these. These are the 2 answers to that equation. Okay, that's it for question 6. If you have any follow-up questions or see any mistakes I made, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day. In question 7, we're asked to split this function up into partial fractions. That means to separate it out into 2 different fractions that when combined again put back into this. Sometimes 3 or 4. Well, no, never. I don't think ever 4 in this in the A level, but sometimes 3. In this case, 2 different fractions will work. It's factors of this bottom row we're looking for. Now, they've already done it. Sometimes it's a quadratic down here and you have to factorize it yourself. But in this case, they've already done it. It's 3a plus 2x, and it's 2a minus x. Now, I'm never good at memorizing the different formulas that work out for partial fractions, like depending on what's on the top row. I nearly always just put a and b, and then I think about, will this work to make what's up here? So what's up here is a number and a variable. So x to the power of 0 and x to the power of 1. And that will appear if I start multiplying across. If I multiply, so to combine these two, let's put a plus in between here. To combine these, we cross multiply. This multiplied by a, this multiplied by b. Think about what you'll get. You'll get a number, you'll get an x, you'll get a number, and you'll get an x. That's what's up here, a number and an x. This will work out fine. If there had been an x squared up here, you would need something that makes an x squared. So we'd maybe have to do like bx plus c or something like that. We don't in this case. So let me go ahead and take that bit out. So using this, if we cross multiply this right hand side, it should equal this left hand side. So let's go ahead and do this. A times this is 2 times a. Maybe we could have used different letters, little a and big A. A times minus x here is minus ax. 3a times b is 3ab. 2x times b is 2bx. And the bottom row, I don't really care. The bottom row looks just like this. I'll put it in for now. The reason I don't care is because what I'm actually going to do is just equate the top rows. Let me say that again. What's on the top row here must equal what's on the top row here. And more than that, the x's that are here must equal the x's that are there. The things without x's up here must equal the things without x's up there. So for example, what has no x here? That's 2aa plus 3ab, and that must equal this 3a. That must equal this 3a. The x's then, let's see, minus ax plus 2bx, that must equal minus 5x. It might not look it yet, but that's a simultaneous equation. I didn't have to write these x's. You could have gone ahead and not wrote these x's as we're saying. We could have just talked about the coefficient of x, the numbers in front of x. And very similarly, we can get rid of these a's. Or if you'd rather, we divide everything by a on this top row, and all these a's disappear. We now have a simultaneous equation with a and b. So let's just go ahead and solve that. Let's multiply the bottom row by 2. We'll get minus 2a plus 4b is equal minus 10. Then we'll add this one with this one here. The a's cancel. We get 7b's. And minus 10 plus 3 is minus 7. We find out that b is equal minus 1. Not finished, we still want a. Use, I guess, this row here. Minus a plus 2 minus 1's. That's minus 2 is equal minus 5. Minus a is equal minus 3. A is equal 3. That will probably get you full marks, I think. But really what they want is, they want you to write this line again. They want you, instead of a, they want you to put a 3 in. 3a plus 2x. Instead of b, they want you to put minus 1 in. It's okay to put plus minus 1, but really that's just minus and 1 up here. And that's full marks right there. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. B is quite tricky. They ask you to obtain an expression of fx, which they gave to us in part A, but we now know also looks like this, in ascending powers of x, up to and including x squared. This is, it's especially tricky because if you weren't able to do part A, you're sort of stuck in part B. You needed something like this. A bit of advice for that. If you knew the answer should look roughly like this, but you just couldn't do it, just make up two numbers. Put 2 and 4. Like, make up any two numbers. You won't get any marks for part A. Well, you might get attempt marks. But you can go ahead and do part B then. Even if your answer is going to be wrong. If your method's correct, you can get full marks. Okay, what on earth do you do in part B? Ascending powers of x should be sparking something in your brain. There's usually a question in the exams about ascending powers. We end up using the binomial expansion. And that's what we're going to use here, but it doesn't look that obvious. The binomial expansion is something like a plus x, like to the power of 6. And that's not what we have here. So what do? First thing is we have to realize we do something like that here. We have, if we rewrite this as 3 times 3a plus 2x to the power of minus 1. If the bottom row is just like minus 1. Minus 1 times 2a minus x to the power of minus 1. Now we have something in a bracket to the power. It's minus 1 though. Is that a problem? Sort of, but we have a general formula. We can use binomial. We can use a binomial expansion for things that aren't natural numbers on a few conditions. On the condition it looks like this: 1 plus x. Then we can put anything we want up here, like minus 1. So that's another problem. This doesn't look like 1 plus x. The x doesn't matter. It could be 1 plus 2x. 1 plus something is more important way to say that. But the 1 is important. We don't have a 1 here. So what do? We just make it look like a 1. So this is equal to 3. I'm going to have to be careful with some brackets here. But if I take 3a outside, 3a outside of this bracket, we have 1 plus 2x over 3a. This is still minus 1. This guy came out of a bracket to the power of minus 1. So be careful. He still is the power of minus 1 there. Of course, this is just divide now. 3 divided by 3a. We'll do the same on this one. That's minus 1. This 2a is going to come out with a minus 1 attached to it. So we'll just put it as divided by 2a. And inside the bracket will be 1 minus x over 2a. Or it might be better to think of this as plus minus x and put a little bracket around that. This is still to the power of minus 1. Now we do have two brackets, 1 plus something to the power of something. That looks a little like our generalized formula for expanding things out. We can go ahead and use that formula. Let me just clean up this little bit here. This is 3 divided by 3a, like I said. So how about we just put it under here, 3 divided by 3a. But then of course the 3 divides into the 3, so we get 1 over a. Rewrite it like that. I'm going to use the entire board here because we're going to expand this out. There's infinite terms in both of these, but they only want up to x squared. So what's the formula say just for this guy here? This is going to equal 1 over a will multiply. I'll open up a big bracket. Actually, you know what? Let's close the bracket here. I'm going to expand this out in here. And then we're going to have minus 1 over 2a. And I'll open up another big bracket. And I'll expand it out in here. The formula for expanding something, 1 plus something to the power of something. It's in your formula, which I have up on my screen here. The expansion of this will equal 1 plus nx. So instead of n, we have minus 1. So minus 1. Instead of x, we have this mess here. This is 2x over 3a. Then we get, there it is there, plus n, which is minus 1, multiplied by n minus 1. That's minus 1, take away another 1. It's minus 2. Divided by 2 factorial, that's 2 times 1, which is just 2. Multiplied by x squared, so that's 2x over 3a and all of that is squared. And this continues on, but they only wanted the x squared term. There's no x out here multiplying into it. There's no x out here, so that they want just up to the x squared term. Let's do the same here. We have 1 plus n minus 1 multiplied by x, that's minus x over 2a, plus n again, minus 1, multiplied by n minus 1, divided by 2 factorial, multiplied by x squared, which is minus x over 2a squared. This again continues on, but we don't care. These are the only terms we care about. Let's go ahead and start multiplying this term in and cleaning up in here. We could also start combining it. I'm going to run out a little bit of room, but you know what, I'll deal with that when I come to it. 1 over a times 1 is 1 over a. 1 over a times minus 1 times 2x. Let's look at the signs first. We have a plus, a minus, so 1 minus, so we get a minus. Top row, we have 1, a 1, a 2x. That's all multiplied to get 2x. The bottom rows, we have a times 3a. That's 3a squared. Okay, this one, let's look at the signs. What plus by a minus, by a minus. 2 minuses, that make a plus. Top rows, 1 by 1 by 2 by 2 by another 2. That's 3 2s, that's 8. Bottom rows, we have, let's see, 2 by 3 by another 3, that's 18. And we have a by a by a, that's a cubed. So 18a cubed on the bottom row. Continue on to here, we have a minus by a plus. We get a minus, 1 by 1, we get a 1, and then 2a on the bottom. A minus by a minus by a minus. Another minus, 1 by 1 by x, we get x. Bottom row is 2a by 2a, that's 4a squared. And let's see what we have here. Minus, 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 minus. That's 5 minuses. Get a minus overall. We've 1 by 1 by 2, by 1 by 1, or by x I guess. So 2x squared. The bottom row we have a 2 by 2 by 2 by another 2. That's 16. And we have a by a by a, that's a cubed. I think I'll have just enough room to put all this together here. I'm looking for 3 terms, the terms without any x's. That's 1 over a minus 1 over 2a. We need the bottom row to be the same, so I need a 2 down here, so I'll put a 2 up there. That becomes 2 minus 1, that's 1 over 2a. Hopefully you follow. All I changed, I multiplied top and bottom by 2. So this and this will go together quite easily. I'll do the same for the x's. The x terms, that's this one and this one. They're bottom rows. This is 3a squared, this is 4a squared. It'd be great if they were both 12. So if I change that, if I multiply that by 3, multiply the top by 3. Multiply this one by 4, multiply the top by 4. What do we have? We have minus 8x minus another 3x. That's minus 11x on the top, and the bottom we have 12a squared. And then finally the terms with x squared in it. This should have an x squared here. Okay, this is, let's see, 18 on the bottom and 16. Well, actually, sorry, first we can, 2 goes into that 8 times. 2 goes into this 4 times, and into that 9 times. Okay, that's a bit more manageable. Bottom rows are 9 and 8. Let's combine them to be 72. Multiply that one by 9, get 72. Multiply that by 9, we get 9. Multiply this by 8, we get 72. Sorry, 72. Multiply 4 by 8, we get 32. I'm sorry, that's a bit messy. I guess we could, I've ran out of room. You could do this in multiple lines. We have 32x squares here, and minus 9x squares, that's 23. 23x squares all over 72a cubed. And that, as far as I'm aware, I have checked the marking, is the correct answer. It's a messy answer, but it is the correct answer. This obviously continues on forever and ever, with one exception. Oh, you know what, that comes up in part C, so I won't talk about something I left out when we started this question. So in part C, they ask you for a set of values for x for which the expansion in B is valid. Now, usually at the start of B, I would have said something about this formula. I left it out because I knew it was coming in part C. But this formula here, this expansion here, is only valid when the absolute value of x is less than 1. Now that means in this case, it's only valid, and that's what they're asking us, it's only valid when the absolute value of 2x over 3a is less than 1. But we expanded two different things, so we need two different ones. This the absolute value of minus x over 2a is less than 1. Both of these have to be true. So what they're looking for is to rearrange this so we get x. We also need to remember, sorry, I wrote it up here, is a is bigger than 0. They told us that at the start of the question. A is bigger than 0. That allows us to just move a without bothering the absolute value. The absolute value only relies on x because everything in here is a known quantity. So we get 2x, the absolute value of 2x is less than 3a. The absolute value of x is less than 3a over 2. That's what we know from there. And we do something similar here. We get the absolute value of minus x is less than 2a. Just move this across. Of course, the absolute value of minus x is identical to the absolute value of x. Because remember what the absolute value does. It just multiplies by a minus if it's less than 0. So if it's greater than 0, we leave it alone. So basically it's two things. It's positive and negative. Well, this is positive and negative in an identical way as that. So we can just write it like that. These two things have to be true. Both of them have to be true. If you don't see what they're saying right now, let me draw them on a number line. We'll go 0 here, a, 2a, 3a, a, 2a, 3a, sorry, minus a, minus 2a, a, and 2a. This one here is saying that the absolute value of x has to be less than 3 over 2a. That's around here. So x has to be less than this or greater than the minus number. It has to be in this world, between these two brackets. Let me just put a couple of lines in there. This one's saying it has to be in this world, between this one and this one. And both of them have to be true. That only happens in this world here in the middle. That only happens when this is the case. So the answer to this is x. The absolute value of x is less than 3a over 2. You could have also broken this out into a plus world and a minus world. It would have got much longer. And I guess we would end up writing something like x is less than 3 over 2a and greater than minus 3 over 2a. I think that's worth more than 1 mark, especially if you did this the slow way of putting a plus and a minus and getting two equations each time and equating them all out. It's certainly worth more than 1 mark, but anyway, you only got 1 mark for that. And that's it for question 7. Okay, thank you for watching, and if you have any questions for me, leave them in the comments. I'll see you next time. In question 8, we're given this trigonometric identity and we're asked to prove it. Nothing too grandiose about proving it. We really just need to show that one side equals the other side when we play around with it. Usually in questions like this, we just take one of the sides, one that looks easier to manipulate, and play it around with it until it looks like the other side. That's what you do most of the time. This question is a little harder. First of all, we can do that to either side. But also, I'd say the easiest way to do this question, because there is many ways, is to play around with both sides. So I'm going to split the world in half here. I'm going to play around with both sides until they look the same. How I'm going to do that? Like I said, there's many ways to do this question. So what I'm going to show you is how I think of it. Some methods that I start a question like this and see how I get to an answer. It might not be perfect for you, so you might want to do this question a different way, in which case this video is probably not for you. But you might just learn how I think through a question like this, and it might help you. Okay, so what do? First thing I do, I try and put everything into the simplest forms I can. And usually that means into sine and cosine, or at least down to tan. I do not like cotan and cosec. I just don't use them. So first thing, I'd rewrite this as 1 over tan squared. That's all it is. It's 1 divided by that minus tan squared on this side, and this becomes 4 over tan 2 theta, and multiplied by 1 over sine 2 theta. Now there's something really obvious to do on the right side. We have a double angle formulas for both tan and sine. So that's one thing I'll be expanding out. On this guy, I'm going to expand the tans out into sines and cosines. So this, remember, tan is sine divided by cosine. So 1 over tan is cosine divided by sine. So this really just becomes cosine squared divided by sine squared, and this becomes sine squared over cosine squared. And we might combine this, we might do some things with this, but let's move over to this guy. The double angle formula for tan tells us, so this is on the bottom row, so it will be inverted. So instead of a 2 tan over 1 minus tan squared, it'll be 1 minus tan squared theta over 2 times tan. Sine 2 theta, the expansion out of that is, we'll leave it on the bottom row, well we have to, 2 over sine theta cosine theta. Okay, at this point doing this question, I was like, I'm still not getting anywhere. I still don't see the clear path to the finish. Now that usually doesn't happen in these questions. Very often at the very start I go, oh, the path would be to move this one, we get somewhere. So at this point I'm still just going, let's change everything into sine and cosine, try and cancel stuff, try and play around with it. And so I'm still left with some tans over here. This becomes, let's see, the 2 goes into the 4. This becomes, let's see, 2 minus 2, I multiplied the 2 in, and instead of tan we get sine squared over cosine squared. Instead of the tan on the bottom, we have a sine over a cosine, and that's multiplied by 1 over 2 sine theta cosine theta. These are multiplying, so that cosine and that destroys each other. Let's see, this we'll separate this into 2 different terms. This is 2 terms, so that's fine. It's 2 divided by what's on the bottom row, 2 sine squared. That's looking okay. So sine squared here and a sine squared there. 2's cancel. We have a 1 here. And the other one is minus 2. Yeah, I'll just write them. No, I have a sine squared, a cosine, and a sine squared. The sine squares cancel. So we're just left with 2 over cosine squared theta. Sorry, 2 theta. So the 2's cancel. Yeah, I'll put a 2 in there. And we're left with a 1. Okay, this is looking maybe promising. 1 over sine squared minus 1 over cosine squared is equal that. They look very similar, but it looks like you can't be right here. It's at this point that I went, I see the path. And I understand if a student doesn't at this point. So I did play around with a few other ways to solve it. And honestly, I didn't find a better way to show you. So my question to you guys is, how do we make this look like this? Let me do one more step on this side to maybe get there. Let's cross multiply. This is the same as cosine squared theta, this multiplied by that, minus sine squared theta over cosine squared theta sine squared theta. And let's cross multiply this guy as well. This will become cosine to the power 4 minus sine to the power 4 theta all over sine squared theta cosine squared theta. Same bottom rows, but the top rows aren't the same. So, like, what do we do here? If you didn't see what I seen on this one, hopefully you see it now. What's this top row? What's special about this top row? It's 2 things squared, the difference of 2 squares. It might say power of 4, but really that's something squared like that, isn't it? It's just something squared and then something squared again. So this is the difference of squares. Now that might not seem, who cares about that, but there's something special about cosine and sine squared, which hopefully we'll see now. This expands out into cosine squared theta minus sine squared theta, and cosine squared theta plus sine squared theta. Look what happens here. Cosine squared plus sine squared. That's just a 1. And sorry, the bottom row is still here. Sine squared theta cosine squared theta. This now is the same as this one. They are equal. I have to say that's probably the hardest proof of an identity I've found. But there is about 4 or 5 different ways to do it. I just couldn't find one that worked out easier. I'm sure there is one, so let me know in the comments and point out how stupid I am for for skipping over the obvious one. Although it was quite nice in the end, I thought. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. For part B, they give a equation. The half of it should look very familiar. It's just like the one above here. They say hence solve this. So the first thing you should do is replace this here with this side. They're saying it will help. Don't think it doesn't help me as much as it usually does, but it does help a bit. So replace this here with the equivalent of this. This would be 4 cotan 2x instead of theta. Cosec of 2x is equal 5 times secant of 2x. Now you might be good at dealing with these cotans and cosecs and secs, but personally I don't. I just changed them all into their original form. 4 over tan 2x and 1 over sine 2x is equal 5 over cosine 2x. At this point it is tempting to go, oh, let's use the double angle formula again, expand all these out. Now I haven't done that, but I'm guessing it probably works, but you're making a big mess for yourself because this all does combine quite nicely. We only have 2 terms. One thing's multiplying on the left, one on the right. So these can cross multiply quite nicely. Sine can just multiply both sides. It disappears over here, reappears over here. And look what happens. Sine over cosine. It just becomes a tangent of 2x. We have a tangent 2x, a tangent, multiply this across. We left 4 left on this side, we'll have 5 on this side, and we'll have 2 of these multiplying each other. So tan squared of 2x. Move the 5 across here, or tan 2x is equal to plus or minus the square root of 4 over 5. Now it is important that you remember that plus or minus. That is going to be very important in this question. You then have to solve this. Your calculator does it. It'll just find 2x for you. The inverse tangent of, yeah, that's right, 2x is the inverse tangent of 4 over 5. Sorry, the square root of 4 over 5. Your calculator will do that for you. It gives you an answer of, let's see, 41.8. That seems okay, but we do need to remember, let me draw it here. We do need to remember what tangent looks like. It goes on forever. It goes on forever like that. The calculator is very stupid. It just gives you the answers in this first little S shape. In this case, the square root of 4 over 5, it would just give you this answer. But this is also a good answer. This is also a good answer. So you do have to be careful which ones you take. In this case, they wanted answers between 0 and 90. But that's for x, not for 2x. So there's a couple of ways to think of this. One, you could just take a few of these, like this, and then the next one here would be minus 180, which if I wrote that down, yeah, minus 138.2, and plus 180, 221.8, and then divide them all by 2. It'd be a silly way to do it because it's obvious this one's not going to be the right answer. What's it, 69 or something? I don't have that. Sorry, 69.1. This one will be a perfectly good answer. I wrote that one down. 20.9. This one won't be an answer. It's 110 and 110.9. They wanted between 0 and 90. This is out. This is out. There's an answer. And it's important that we still have the plus or minus because we do get another answer. Yeah, let me say another way to do this in a moment. I'll just finish off though. 2x is also equal the inverse tangent of minus 4 over 5. Sorry, square root of the minus definitely should be outside the square root. The problem here is your calculator is very stupid. It will only give you one answer, and that answer is minus 41.8. Same as this. So you might be, some students might go, okay, that's not okay. Divide that by 2, we get a minus. That one's gone. It's not a good answer. But remember, it told you this answer here. This is still an okay answer, and so is this. Obviously that one's not the right one. This one's bigger than 90. Add 180 to that. We get 138.2. That's bigger than 90. Some students throw that away because of that. It's 2x here. Divided by 2 though, it's perfectly okay. It's 69.1. So there are two answers. This one here and this one here. Let me start again on this, explaining what happened there. You are often going to get to a point where your calculator gives you one silly answer. You need to think it through. You actually have to use your brain. Your calculator is not going to be able to do this work for you unless you have a really good calculator. You have to think through, what answer has my calculator given me? What other answers are there? I find it just helps to write a few of them down. In this case we had to do the question twice though. Just write a few of them down and think through what happens next. Sometimes it's a 2x here, sometimes it's a x minus 5 divided by 3. You really have to think of what's going to happen to these numbers before you get your final answer and you get to the point where they told you x has to be between 90 and 0. Also, they sometimes might tell you the answer is between 270 and 360. So you have to be quite careful about that as well. Alright, I don't think I explained the last bit too well, but ask me in the comments if you're unsure and I'll do my best to help you. Thanks for watching and have a great day. In question 9, we're given the position vectors of 3 points, A, B and C. And we're asked to find the vector equation of a line that passes through B and C. Let me spell this out a bit here. B and C will just make up 2 random points here. And we have the origin O. The vector equation for a line, for any line, let me put in a line here. We tend to write like this. We use OR as the starting point. It's really a set of instructions on how to get from 0, from the origin, to any point on this line. So those set of instructions are, we can get different answers, but they're standard in the sense of, I tell you how to get to anywhere on the line. So an instruction to get from OB or OC, which is we have right here. And then once we're on the line, we're going to get a vector that moves along the line. In this case, I think I did BC. So let me write that out here. Instruction to get to the line. I'm going to do OB. So that instruction would be 1, 3, minus 2. Then I'm going to add on to that a multiplier, a scalar. We use lambda, multiplied by a vector that goes along that line. So we get to the line and then we can move any number along the line. I'm going to use BC, so 1 BC will get me here, a half BC will get me here, 2 BC will get me there. This will get me anywhere on the line. All I'm missing is a vector on the line. So I need BC. And to remind you, BC is again instructions how to get from B to C. Vectors are interesting though. That's the same as going from B to O and then from O to C. Vectors don't care how you get there. It's just where you start and where you end. Start at B, ended up at C. BO is the same as minus OB and OC is OC. This should actually be OA, OB and OC. I just don't bother writing them, it's quicker. This is the same as C minus B, which is 2 minus 1, gives me a 1, and minus 1 minus 3 gives me a minus 4. 3 minus minus 2 gives me 7. So that's a vector that's on this line. This is a vector equation of this line. Sorry, just checking my notes. That's a 7. This should be a 7 here. This is 3 take away 2. So that's plus 2. Instead of the 2 minuses, I got 2 minus 2's, which was a bit wrong. So that should be a 5. Sorry, over here should be a 5. So that's our final answer for part A. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. For part B, we'll continue on with our drawing over here. They tell you about a point P, that's the foot of a perpendicular from A to the line L. So let's just put A somewhere over here. Here's the line L, the perpendicular. That's just moving up, so at a right angle to the line. It doesn't have to hit here, maybe it's over here, maybe it's down here. I don't really care, it's just a rough idea we're looking for. And we're looking for, this point here is the point P. So how do we find P? Well, first of all, we have a representation for P already. This equation here is every point on the line. That's what this represents. So P is in here somewhere. So I could say the point P is actually equal to this, 1, 3, minus 2, plus, I just don't know this number. So you can leave it as lambda, that's fine. I'm going to replace it with just a small letter P. Yeah, we'll leave that as OP. Small letter P, 1, minus 4, and 5. And we can actually write this even better. We could put these together. This is 1, well, let me write here. This is 1 plus P times 1. That's plus P. This is 3 take away 4P. 3 minus 4P. This is minus 2 plus 5P. This is a representation for P. So at this point, you could really argue what we're actually looking for, because they're looking for P, we're looking for this. If only we knew what the letter P stood for, or you might have lambda here as well. Right, so we need something, we need somewhere to get a clue from. The clue is actually the right angle. When we get the scalar product of two vectors, the right angle is very important, because if we get the scalar product of two vectors that have a right angle, the answer is 0. So we get an equation, we get an equal 0. That would help us a lot here. So what we're going to end up doing is we want a vector that's on this line. We already had that. That was this one here. That's a vector that's going along this line. And we really now just want a vector on this line. So we have OP is this. We'd love to get PA or AP. So, and we can get that. AP is just equal to OP, or yeah, let's leave that as OP minus OA, by the same logic as up here. And we have A here, we have OP here, so we can just do this one, take away this one. 1 plus P, take away 1 is just leaves P. 3 minus 2, that becomes, that's 1 minus 4P. And minus 2, take away 0, it says minus 2 plus 5P. This is a vector AP. So what we have now, if I draw that picture once more, what we have now is a vector that's, oh sorry, we got AP. Okay, let me draw that, that's fine. We have the point P from this picture here. I got the vector AP, which is going this direction. And we also have this vector BC, which is going this direction here. These two vectors, this one and this one, looks like we know there's a right angle between there. And we didn't have to be careful to get, for example, you might need to get PA if they told you the angle was 30 degrees or something. Because it'd be very different getting AP to PA. 30 degrees and 150 would be this side. But 90 and 90 were fine. There's no issues in that. So what we now know is this vector and this vector when we get the dot product of the two of them, it equals 0. So let me clear off the board and I'll do that. Okay, I've wrote out those two answers we got here. We have a vector AP and we have vector BC. We just need to dot product these two. Well, let me write that out. AP dot BC. Make sure that dot's nice and big. The dot product or the scalar product. That's just the x parts multiplying, the y parts multiplying, and the z parts multiplying, and adding them all together. So P multiplied by 1 is P, plus 1 minus 4P multiplied by minus 4. Minus 4 by 1 is minus 4. Minus 4 by minus 4P is plus 16P. And then we're going to add on the bottom one. That's 5 times this. That's minus 10, and that's plus 25P. Be careful any signs. I put a bracket in on that one. So we have 16P. Oh, sorry, all of this equals 0. 16P plus 25P is 41P. Oh, sorry, plus another one, so 42P. And that's equal to, let's see, minus 10 minus another 4 is minus 14. Let's move it over to equals and we get a plus 14. That's P is equal to 14 over 42. That goes in 3 times. Check in your calculator if you're not good at doing that. So P is equal to 1 over 3. Remember, that's not your final answer. They wanted the position vector of P. We have that. It should be earlier on in your page if you're doing all this. I've wrote it out. But we had that as 1 plus P, 3 minus 4P, and minus 2 plus 5P. But now that I know what P is, this actually just becomes 1 plus a third is 4 over 3. Let's see, 3, so this would be 9 over 3. Take away 4 over 3, that's 5 over 3. This is, let's see, minus 6 over 3 plus 5 over 3. So minus 6 plus 5 is minus 1. So we get minus 1 over 3. Double check that on me, but that's my answer for part B. Then finally for part C, they tell you about point D. That's a reflection of A in L. So first of all, what does that mean? We can draw that one quite well. Well, remember L is this line here. Here's a reflection of that in that is just rotating it over like this. So we get this point over here, D. And they ask you to find its position vector. There's only 2 marks for this, so this should tell you there's probably a few clues here. There's a few easy ways to do this maybe. The secret here is that you know the point A. Let me put out A here as a 1, 2, 0. You know the point P. We just found that. Let's put that here. P is 4 over 3, 5 over 3, and minus 1 over 3. And we're looking for the point D. Now the secret here is however you get from A to P is the same way as you get from P to D. So if I told you how to get from A to P, like think in a 2-dimensional world, I know we're not there, but in a 2-dimensional world, and if my drawing was correct, I'd just say go left and go up. Go left whatever amount and up whatever amount. That same direction would get you from P to D. And that's the secret answering this. How did I get from A to P? What I did is, this is the same as, well, let's clear this off. Instead of 1, 2 and 3, 1, 2 and 0, let's put this down as 3 over 3, 6 over 3, and 0 over 3. I tend to do this in my head, but I know this probably helps a few students. This is the same number, but 3 over 3 is the same as 1. So how did I get from A to P? Really, what I did is, let's put a new vector here. I added on 1 over 3. That's how I got from this to that one. Then, how did I get from here to here? Well, I took away 1 over 3. Or I added on minus 1 over 3. How did I get from 0 to minus 1 over 3? Again, it was minus 1 over 3. That's the set of instructions that gets you from here to here. What I'm saying is the same set of instructions will get you from P to D. So where would that end up? 4 over 3 would become 5 over 3. 5 over 3 would become 4 over 3. We're taking 1 away. And minus 1 over 3, take away another 1 over 3. be minus 2 over 3. That's the position vector for D. And that's it for question 9. If you have any follow-up questions or you see any mistakes I made that I haven't already pointed out, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day. In question 10, we're asked to solve a differential equation. That takes the form of an equation with a dy dx in it. And how we solve these nearly always turns out the same. I don't want to say always because I'll be proven an idiot, but every time I can think of turns out the same. What you want to do is you want to separate this dy dx, so we get dy on one side and dx on the other side. With the dy, we get everything that has a y in it, and with the dx, we have everything that has a dx in it. So let's do that now. We have a sine 2y on the right, so if we divide that across, we leave this guy where he is, sine 4y, and be divided by sine 2y. The x's, they're already on the right. We have an x and a sine 3x. So this question, instead of the one up here, we can think of it as this. And how we do it is we just integrate both sides. So we add an integral in here. It now becomes two questions. Integrate this and integrate this. That's how I'm going to look at this. I'm going to just separate this. I'll work on this on its own, partially because I don't have a big enough board. And then I'll work on this on its own. It's okay for you to do this as well in the exam. And then later I'll put them back together with this equals. So first of all, let's start with this left hand side, this sine 4y over 2y. You can't do it as things stand. That happens all the times in integration. We have a good few different methods to try and solve things. You could try a substitution. You might want to try substitute the 2y or the 4y and see how that gets you. It's not going to get you anywhere. You could try it, and this will happen in the exam. It happens to everyone. You attempt something, you go a couple of lines down, and then you just give up. You realize you're wrong. You're doing maths, and you realize, this is the wrong path. Just put 1-2 lines through it and move on. Try the next idea. So next, you might try integration by parts. It doesn't look like two things multiplying, but it is. It's this multiplied by 1 over that. You could try that. It might take you another few steps to realize, oh, that's not looking good either. When you're dealing with trigonometry or trigonometric expressions, it's always worth thinking, can I change this into something? And that's what we're going to get here. We have a formula for sine 2y. You could try and change that. That's probably the wrong path to take down, because what gave me a hint in this question was the fact that 4y is 2 times 2y. That set off alarm bells in my head. It made me think of the sine 2a formula, where sine 2a is equal 2 times sine times cosine, but not for the bottom row, for the top row. Let me show you what I mean. Let's rewrite all of this, just the left hand side now. The top row, let's realize this. If I rewrite it as 2 times 2y divided by sine 2y, this is what I want to change. And let's change that into the top row, so it will become 2 times sine 2y cosine 2y. So that I've just used the double angle formula for sine. This is 2 times something. Becomes 2 times sine, that's something. Let's put a bracket in there, like that. But hopefully at this point you should be like, oh yeah, of course, because the bottom row also has a sine 2y. They just cancel quite nicely. So all of that work got us to, instead of this left hand side, got us to the integral of 2 can come outside of cosine 2y with respect to y. This is something we can integrate. It's not too difficult. We sort of need to substitute the 2y. So sometimes I do that slowly. I write y is equal, u is equal 2y, and I substitute it in. But I think that most students like to do this just in their head. It's a simple enough way to do it. We're replacing this 2y with something, a u, if you want to do it formally. but it's just cosine of something. The integral of that with respect to something is sine of that something. So the integral of this, the 2 is still out here, just becomes sine 2y. But we end up dividing by the derivative of this thing we've replaced. You can see that more clearly if you did the whole substitution. So we'll end up dividing by 2 here. Most students just remember cosine or sine or tan of any integer here. So 8y or 7x or anything like that. You just end up dividing by that number. And you don't have to remember it. You can use substitution or go through it in your head. Anyway, that cancels down, and this is the integral of this with just some constant. I'll call it C1 here. Right, that's the left hand side done. I am going to clear off the whole board and let's do the right hand side. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Right, let's leave the answer to the left hand side here and we'll concentrate on this right hand side. How do you integrate x multiplied by sine of 3x? We should go through the same steps we did before. Just keep trying things. There's really 3 main things to try. Substitution, playing around with the trigonometric expression, and integration by parts. That is going to be the answer here. Substitution, it's not really going to work out for you. If you substitute 3x maybe, you could also substitute x because they're practically the same. There's only a multiple of 3 between them, but we'll still be left with a u times sine a u. So that's not going to work out for us. We could try expanding sine 3x out. There's a couple of ways to do that. There's a double angle formula, or there's just 2 different angles added together. But really you're just going to make it more complex. There's nothing really nice to cancel with. This is a trigonometric expression and this isn't. So they're not really going to cancel too well. So we're really going to be left with integration by parts. So integration by parts tells us if we have 2 things integrating, in this case this thing and this thing, one of them has the dx with it. That's not so important for you to remember. But when we have 2 things integrating, that's the same as multiplying them together and then take away the other way around, v du. Now students tell me they have this list of rules how you can integration by parts. I don't bother with them. I just write down u, v, du and dv. Or instead of du, I don't write it myself, but I think it helps to think of it as the dx here. So I want u and I want the derivative of it. I want v and I want the derivative of it. The thing is, 2 of the answers are here. U and dv dx is here. You just have to decide which is which. There's no harm in just writing down whichever one, trying the question and seeing if it gets too difficult or you fail somewhere. But you can also do it in your head. For example, well, let me write the wrong one down. Let me write sine 3x here, sine 3x and x here. What's going to happen is we are going to differentiate this, which we can do. Yeah, I'll just put that down. Cosine 3x and 3. And we're going to integrate this, which we can do. And we're going to ask ourselves, instead of trying to do this question, these 2 together, is it easier to do these 2 together? That's how I think of integration by parts. And it's clearly not. X squared times cosine 3x, that's similar to this. It's actually even just harder. There's an x squared now instead of just an x. So the answer is, well, hopefully the answer is the other way. And I don't tend to write this. I tend to think this in my head. I think to myself, if I differentiate this and well, I think, can I differentiate and integrate first of all? So I can differentiate that, integrate. So that's no problem. So if I differentiate this, that'll make it simpler. It'll just be a 1. And if I integrate this, it doesn't make it much harder. It just becomes a cosine. Sine and cosine are very similar. So I already know this is this is what I should do. An x here and a sine 3x here. because the derivative of x just becomes 1, and the integral of sine 3x, the integral of sine is minus cosine 3x, and we divide by this 3. So we end up getting that divided by 3. So the question is this multiplied by this easier to integrate? Let's write that down. Instead of doing all of this, is it easier to, let's not forget the u times v, is it easier to do, well, minus x cosine 3x over 3. We don't have to do anything to that, so that's definitely easier. Is it easier to do minus the integral of minus cosine 3x over 3? And yeah, this is quite simple to do. We can, first of all, we can, two minuses make a plus, and we can bring the 3 outside to be 1 over 3, and we're just left with this integral. Quite simple. It's similar to what we've already done on the other side. This whole right hand side now becomes minus x cosine 3x over 3 plus 1 over 3. The integral of cosine is sine 3x, and then we divide by another 3. And that's it, plus some constant, we'll say constant 2, and we can also put these two 3's together to get 1 over 9. Next up, let me just clean all this off, and I'll write down, I already have one side of it here, I'll write down the two answers here, and we'll continue from that point. Okay, here's the two answers we previously got. Sorry, I'm missing a constant here. This is plus C2 I wrote. You can combine your constants. In fact, let's do that right now. My C2 here, take away my C1, just becomes a new constant. So C3, or again, you can just keep writing plus C here. I'll try and be consistent. This is pretty much it. They didn't ask for y in terms of x. They asked for a relation between x and y. This is already that. There's y on its own pretty much over here, x is over here. That's a pretty good one to do. You could of course just get the inverse sign of both sides. It just makes a bit more of a mess. Multiply it by a half, you have y equals. With that said, we're not completely done. They don't want the constant. They gave us information to get rid of the constant. They told us that there is a point where y is equal pi over 12, and there's another point where, same point where x is equal pi over 2. Here's an equation with x, y, and a c. I know what x and y is, so I can find c. That's what they want you to do. You're going to lose probably 2 marks if you've done everything else and don't finish with this. Let's put it all in. This will become sine 2 times pi over 12 is pi over 6. That's sine of 30 degrees, which is just a half, is equal minus 1 over 3. What's that? Pi over 2 cosine 3 pi over 2. We'll draw a picture to figure this out, or just use your calculator. Plus 1 over 9 sine 3 pi over 2 plus some constant, C3. Let me just draw cosine here and sine. Cosine looks like this. This is 2 pi. That's pi here. So which one we got? We have cosine 1.5 pi's. That would be right here. That's just 0. That whole thing goes to 0. We have, let's draw sine. Sine looks like this. You can let your calculator do this, of course. That's pi, that's 2 pi. We're interested in 1.5 pi again, that's here. That's minus 1. This just becomes minus 1. And as I said, use your calculator for this, or I just happen to remember it's a half. That becomes a half. So write that out again. We get a half is equal to minus 1 over 9 plus C3. Rearrange that, we get C3 is equal to a half plus 1 over 9. Let your calculator do it, or put it together yourself. This would be 9 over 18 plus 2 over 18, which is equal 11 over 18. I think you would get full marks for this, but maybe not. Let me just squeeze in a box here. What the examiner what they really want to see is your final answer is this line here again. Sine 2y is equal minus 1 over 3 x cosine 3x plus 1 over 9 sine 3x, and instead of just constant, they wanted to write 11 over 18. This is definitely full marks. I think you probably got it down here. Okay, that's not it. Sorry, I thought that was it for question 10. That was 8 marks. That was a good long question, but they added in one more bit. Let me clear off the board and try and answer that. For part B, they pretty much tell you find y. They tell you what x is, but they ask you what y is. It's only 2 marks for this, so it doesn't take us much work. I left this final answer we had from part A. So let's write it again with what they told us. X is equal to 0. We'll worry about what y is later. They tell us y is between 0 and pi over 2. So if I write all this again, I get sine of 2y is equal. X is 0. So 0 multiplied by anything, that's gone, it's 0. X is 0 again. 3 times 0 is 0. Sine of 0 is 0. That's gone. We're just left with 11 over 18. That's why it's only 2 marks. Find out what y is. We saw this 2y is equal the inverse sine of 11 over 18. But let me stop you there. This will give you an answer, of course. But remember, your calculator is stupid. It'll only give you one answer, and it might not even be the right answer. I want you, whenever you do this inverse sine or inverse cosine, to think about the question. They told you the answer has to be between 0 and pi over 2. This is 2y though. So one way to do it would be to realise that 2y has to be bigger than 0 or pi. That's one way. And I like to draw this. I like to draw sine of something. Sine of something looks like this. And this is 2 pi up here, although this is for 2y anyway. And they're doing 11 over 18, somewhere here. You're going to get this answer, and many other answers. But we need to realise that it's just these two we need, because 2y is between 0 and pi. You could also just get out every answer that the calculator or the sign would give you. Write out 10 of them. Or I sometimes recommend writing about 4 of them out. These two, the next ones. And then just dividing them all by 2, seeing which of your answer fits in and throwing the others away. Or you could think of it out first and say 2y is between 0 and pi, therefore these are the only 2 that work. Either way, you should get for your answer, your calculator will first of all give you 0.65746, but then you need to use your brain. That'll be this one. You need to use your brain to figure out this one here. If this is 0.6 away from 0, this is 0.6 away from pi. So pi minus this is your other answer. That'd be 2.4841, something like that. But your final answer is what's y? Y is equal half of both of these, which is 0.329 is one answer, and half of this is 1.24. Remember, they didn't ask for how many decimal places, so it's always 3 significant figures. 3 significant figures, 3 significant figures. I often say to students, it doesn't matter if you have too many. So I nearly advise students just always give 5 significant figures. It's make sure you won't lose a mark. Okay, that's it for question 10. If you have any follow-up questions from that, let me know in the comments. I'll do my best to answer. Thanks for watching and have a great day. In question 11, they give us this formula and this graph here, and they want you to show something. Show that tan of 2a is equal minus 4a when x equals a. I would try not to worry about that. Often when they give you the answer like that, show this, I suggest to students just try the question without thinking about it until later. There will come a point where you want to look at it and make your answer look like that answer, but for now you should just think that they're asking you about the maximum point, the maximum of an equation. So what you should be thinking is dy dx, and what's more, at the maximum it equals 0. So we now have an equation to start. They wanted you to find an equation. We now have an equation. This is the equation they wanted you to start off with. So our course is clear. We need to differentiate this. Whenever I have a square root, especially in differentiation, I nearly always just rewrite it as x to the power of a half. So let's rewrite everything there. So I want to differentiate this. This is two terms. So we're going to use the product rule. And within the product rule, we're even going to use the chain rule, although it's not too bad on this one. Okay, so the product rule tells us that, let's differentiate the first one. That becomes a half times x to the power of minus a half. Leave the second one alone. Sine 2x. Plus, leave the first one alone. That's x to the half. Multiplied by the derivative of the second one. The derivative of cosine is, the derivative of sine is cosine. Or I should say, we have a problem here. 2x is too complicated to do. So we would need to use the chain rule. We can do it in our head though. The sine of something, the derivative of sine of something with respect to something is cosine of something. Use any letter you want, u or something there. But we've replaced something there, so we need to get the derivative of that something and multiply it by. That something was 2x. The derivative of 2x is 2, just multiply it by that. Most students just remember the derivative of an easy thing like this, a multiple of x is just do it as normal and multiply by the number. But still, I think it's better to learn it the proper way. Okay, this all equals 0. This is an equation. We can clean this up. Let's move one of them over the equals. Let's move this guy over the equals. And we'll change these to the power of a halves back into the square roots. So this will become minus a half. Minus a half times sine 2x. And this square root of, this is a minus square root. So that means it's on the bottom row. So that's divided by square root of x. And we'd leave this on the other side. That'd be a square root of x, 2 square root of x times cosine 2x. Now at this point, I looked at the answer they gave us. The answer has tan in it. It has a 4a in it. But the tan is what jumped out at me. Because my answer has a sine and a cosine. They go together to make tan. Before that, I guess we could clean a lot of this up. There's a 2 and a square root of x on the bottom over here. Let's multiply both of them across. We'd just be left with a minus sine 2x on this side. This times 2 is 4. Square root of x by square root of x is x. And we leave cosine 2x there. We now have 4 times something. That's what we wanted. But I wouldn't worry about that too much yet. Let's just get that tan. We have a sine 2x, a cosine 2x. If we divide both sides by cosine, we'll get that. That just becomes pretty much the answer. Minus tan 2x is equal 4x. A couple of problems. Well, first of all, they want the minus the other way. So that's tan 2x is equal minus 4x. One problem really, they wanted a. They want tangent of 2a is equal minus 4a. At any point after this line or in this line even, we could have replaced x with a, because they told you that x was equal to a at this point. That's what we were doing here. We were at this point because we were at equal 0. So at any point you want, you could have put a in. I'll just wait till the end. So that's tan of 2a is equal minus 4a. And that's the answer to part A. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. For part B, they want you to show by calculation that A is between 0.9 and 0.95. This question comes up all the time, and there's a couple of ways to do it, but my main way to do it is just fill in the two numbers they gave you, sorry, 9, 5, to this equation. They've given you this answer already. This is two sides to this equation, the left side and the right side. If we think of these as separate functions and fill these numbers in, we're gonna, I'm skipping to the end a bit, but if we fill these numbers in and if we find out this number is bigger than that one, and then if we fill the other number in and find out it's less than that one, it means they must cross in between. If we find out the left side looks like this, and then it looks like, I don't know, this or something, they must meet somewhere. The answer must be in the middle. Let me show you a bit more. Well, that's the main idea. I'll write exactly what I think you should do in the exam, or certainly enough that you will get full marks in the exam. I am going to find tan 2a at this point, and I'm going to find minus 4a. I'm going to put these both in the calculator. I have the answer already out here. If you put 0.9, tan of 2 times 0.9 into the calculator, you will get minus 4.286, and if you put this in, you get minus 3.6. At this point, I would write something like, the tan 2a is less than minus 4a. And I do the same over here, tan 2a minus 4a, find out what both of them are. This one is minus 2.927, this is minus 3.8. This time I point out that tan 2a is bigger than minus 4a. And that would be it. I'd write therefore, therefore a is bigger than 0.9 or less than, is between 0.9 and 0.95. This is enough to show me. For the reason I said here, this should be on top of each other, I suppose. If I put in like 0.9, 0.95, if one of them is above the other and the other is below the other, no matter how you get from here to over here, once you can't go back in yourself, and I don't care if I do it 3-4 times, there has to be at least one answer between these 2 points. Maybe there's 2 or 3 answers, but there has to be at least one answer. There's no other way for this guy to get to here without crossing these two. So there has to be a solution in between. That's all this is saying. In part C, this is a question I don't think I've seen before, and I would forgive a lot of students for not knowing what they even want you to do here. I think most people will be able to do the next part D. It comes up every year. But what are they asking you here? Prove or to show that this converges to A. How do we do that? We know about A up here, and this looks very similar, but not quite the same. What do they want you to do? Well, what they want you to do is show that this is the same as this. If it converges at A, first of all, the nth x and the xn plus 1, as we'll do in the next part, they'll start being the same number if we go further down the iterations. So I can first of all rewrite this as A equals 1 over 2 pi minus the inverse tan of 4a. So that's the first thing I could do. They might try and give you a mark for that. And you could try just multiply this out, multiply both sides by 2. 2a is equal, and then maybe take pi off, take pi away. So 2a minus pi is equal to minus inverse tan of 4a. We could get multiply both sides by minus first of all. That becomes a plus, that becomes a minus. And we could get tangent of both sides. The left side we'd get the tangent of minus 2a plus pi is equal 4a. There's some similarities here, but not quite. Really the meat of this question is they want you to show that this is the same as this. So I'll do that by drawing it out, and hopefully some students see it, because it is at this point we're getting a little more common. Tangent looks like this, whereas this is 90 degrees, or pi over 2. This here is pi, this is 2 pi. Tangent repeats every pi. It's identical, it's 0, it's 0, it's 0, every pi. it's, I don't know, let's say this is 5. Add pi on, it's still 5. Add pi on, it's still 5. Adding pi on does nothing. It doesn't change the answer for tan. So this answer is identical to this. That still equals 4a. Now we're nearly there. You don't have to explain why you know this, but I'll talk through it. This is then the same as minus tan 2a. What I mean, you don't have to explain this. Yeah, you don't have to write anything I'm about to say down, but hopefully you do know this. A minus in here. So for example, if I put in, let's say, I don't know, pi over 6, and I get an answer here. If I put in minus pi over 6, I get a symmetrical answer. If I got plus, I don't know what the answer is there. Let's say 1 over square root of 2. I don't know what it is. The answer down here is minus 1 over square root of 2. If I put in pi, I get 0. If I put in minus pi, I get minus 0. Still the same thing. If I put in this number here, let's say that's, let's say 4. Pi plus a small bit, 4. I get this number. If I put in minus 4, I'll get the same thing, just a minus. That's what we're saying here. So this is still equal 4a. Change sign on both sides, and we get what's up there. Equals, sorry, minus 4a. So this is the same as this. So the answer to this is clearly a, because we have a in it. This converges to a. That's what they want you to show. But I don't think, I think a lot of students would have gone, sorry, what do you want? I guess the hint here would have been just play around with this. Play around with it, and you hopefully could have got to a line that looked something like this. And once you got here, to get that mark, or yeah, you probably could have got 1 mark to get to there. To get that next mark, they really wanted you to notice that this is the same as this. This is the same as this. And boom, we're back to this original one. On to part D. Now, you are probably tired if you're doing this exam. It's the last question of the exam. Although you don't have to do the questions in order, but most people do. So you're quite tired. Still, there's no excuse not to get these marks. It's the same question, nearly guaranteed every year. You have a formula that maybe you had to find yourself, or usually they give it to you, like they've done here, and we just have to put numbers in until we find an answer. We get to decide the first number. Let me do it all here, because I'll put it all on top of each other. We get to decide the first number, the first guess we make. Sometimes they tell us that. In this question, they did tell us that the answer was between 0.9 and 0.95. So I will guess my first answer is 0.925. Doesn't matter. You could guess 0.9, you could guess 0.95, you could guess 1 if you wanted. It's fine. What we do next is we use this formula to find our next number, our x1. And that's just by filling this in. Yeah, you'll see what I mean here. It's a half multiplied by pi, take away the inverse tangent of 4 times. If it's x1 is out here, this must be x0. Because if x1 is here, n plus 1, this is 1 less. Another way to write this would be xn and n minus 1. That's the way I learned it, at least. So if x1 is here, x0 must be in here. So this is 4 times x0, or in this case, 0.925. You just put all that in on your calculator, and you'll get, well, you might have a different number if you started at a different number, but if you start the same as mine, you get 0.917380. They asked to make sure you tell them six digits here, but they also wanted the final answer to have 4 digits. So I'll write both of them. 0.9174 would be the 4 digits. What we're going to do is we're just going to do this as many times as it takes until our 4-digit number stops changing. Basically, so it repeats twice. Yeah, and that's it. You just have to put this in your calculator. There is one shortcut you can do. I'll write it out here. What I do is I put this number in on my calculator, my first guess, and I press equals. That makes your calculator remember this number as the answer. Then I put this whole formula in the calculator all in one go. I put in lots of brackets to make sure I don't mess up. And instead of this here, there's a button on your calculator that is answer. Instead of this number, I press this button at this point, and I close all my brackets and I press equals. I still get this number. But the magical thing that's happened now is your calculator now remembers this formula. It remembers, instead of the number here, to always use the answer. And now the new answer in your calculator's memory is this one. So if you press equals just one more time, it'll do this whole formula for you with this new number in it, and you'll get 0.918425, which is the same as 0.9184. Not the same, so we stay going. Third guess, again, just press equals on my calculator, it does it. And 0.918281, which is the same as 0.9183. Not the same yet, we have to stay going. In paper 3-2, in the same year as this, they had to do this like 8 times. I've never seen that much. Usually it's 3 or 4 times. This is the fourth iteration. Fourth iteration is 0.918301, which that rounds off to 9183, same as this. So I can confidently say my final answer is 9183. That's correct to 4 decimal places. Because your if you've done this trick I told you about, you can actually just press equals in your calculator 5-6 more times, and it will just get better and better answers. So in this case, this guy converges quite quickly, because that's what tan goes off quite quickly. So the fully correct answer, you don't need it, the exam didn't ask for it, is this is to 8-9 decimal places. But that's perfectly correct. But that's obviously correct to 4 decimal places. Okay, that's it for question 11 and this whole paper. If you have any questions for me, or you see any mistakes I made, or just any questions in general, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day.